and challenging the existing culture. When we try to get a project approved, typically our corporate management wants projects that are going to increase throughput or be new products. Energy projects are a challenge to get approved, but we've gotten 2 fuel cell projects pushed through, and we're currently able to get other energy projects. So we've got people thinking in the right direction now. Final thoughts. I showed the performance, but I try to keep in mind that fuel cells are an emergent technology. There are inherent risks, and we knew that when we went into this. But we have had a positive impact on our corporate sustainability goals, public relations-wise. It's a very good story. And Pepperidge Farm and Fuel Cell Energy are committed to getting this fuel cell up to the target outputs. Thank you.
Good morning. My name is J.D. Van Wahy. I'm with Pacific Gas and Electric Company. And I want to talk about our use of hydrogen fuel cells as backup power. First, a little bit about PG&E. We're a gas and electric utility in California. About a 100-year-old company with about 20,000 employees. Fairly large utility, one of the largest in the country, 70,000 square mile territory. About 1 in 20 Americans receives their gas or electricity from PG&E. As you can see from the slide, 139,000 circuit miles of electric lines, a lot of gas infrastructure. So a lot of territory to cover, a lot of people to serve. One of our critical pieces of infrastructure is our telecommunications infrastructure. We have our own internal networks that connect our offices, service centers, call centers, power plants, electric substations, hydroelectric facilities, gas facilities, as well as communications to all of our field crews. Just a brief background here about DC power and telecommunications. Primarily, telecommunications equipment all runs on DC power. It's the most common configuration you'll see. And this is just a very simple block diagram to show how that's typically configured. You'll have AC from your utility, which is rectified in a DC power plant and provides DC power to your load. And then you'll have batteries in parallel with that. If there's any interruption in the AC supply, the batteries will carry the load. The equipment sees no interruption. It's a very reliable configuration and very common. We typically, at most of our sites, will employ a motor-driven standby generator with a transfer switch. If there's a loss of utility power, the generator will start, provide power until the utility returns. Most of our standby generators are propane-driven. We do have some diesel, but in our telecom sites, it's primarily propane. And so what we did was, just to show you in this same simple diagram here, was we've used hydrogen fuel cells as a replacement for the standby generator. So if there's a loss in AC utility power, the fuel cell will start, provide power to the equipment until the utility returns, and then it'll shut down. So just a little bit of our history here. Back in 2005, 2006, looking at our infrastructure, we had a lot of aging infrastructure, a lot of older generators that were requiring replacement. And rather than just replace them like in kind, we started to look at alternatives. And that kind of brought us to fuel cells. We did a pilot project in 2006. We selected the Rely-On fuel cell. There was several fuel cells on the market that looked like they would be suitable, but we selected the Rely-On. We installed it at a repeater site near Monterey, California, is an interesting site. It's actually near the Pebble Beach golf course. So it kind of sits out on the peninsula, right on the coast of California there. And it's not a very remote site. You know, it's near the town of Monterey, and not a lot of electric outages there. But the first year that we installed it, a very bad storm came through and knocked down so many trees in that area that it was actually 3 days before they could restore power to this site. And the fuel cell worked perfectly. So, you know, in the electric utility business, you never hope for an outage, but it was a great test of the, or an example of how the fuel cell can work in that situation. Following that, we installed 3 additional fuel cells at 3 telecom sites in our network, 2 mountaintop sites and 1 hydroelectric facility. And they were larger units. The initial installation was a 1 kW fuel cell, and the 3 units we installed in 2008 were 2 kW fuel cells. This year, we are deploying 9 fuel cells. They're being deployed as I speak, and we already have plans for additional installations next year. So some of the advantages that we saw with the hydrogen fuel cell is obviously they're automatic, so they don't require any intervention. If there's a loss of utility, they'll start. They use commercial-grade hydrogen, which was readily available. We can easily calculate the runtime that we will have based on the number of cylinders and the electric load. That was one of the big factors for us was runtime and how long we would have backup power. Another advantage, not a big one, was zero noise level. The generator that we had in Monterey actually sat in an area with some very expensive homes around it, and when the power did go out, the generator would start, and the homes that were in the vicinity of that site would hear that generator running. And we actually had some neighbors comment that they appreciated that the fuel cell didn't make any noise at all. So we really just have some niche sites where the fuel cell is the right solution for us. And some of the criteria we look at is DC load. You know, we need a site that has a small enough load that we can serve it with a fuel cell. What are our standby time requirements? And no 2 of our sites are alike. So we have some sites that are urban, some that are rural, some that are very, very remote. We have sites in the middle of the Mojave Desert, sites at the top of the Sierra Nevada mountain range, and some sites we will want runtime that we can measure in weeks. We have sites that we can't access during storm season. So basically from maybe November to June that we can't even access. So that's an important criteria. The fuel cell produces DC, so if we have a large AC load component, then that's going to be a factor. Location and access. This is a chart just to kind of talks about some of the differences or how we view the 2, generator versus fuel cell. In our network, we rarely purchase a generator smaller than 20 kW, regardless of the load. And the reason for that is smaller generators typically don't have the automatic start and monitoring capabilities that we require. So all of our remote sites are monitored. We want to know if the generator is running and some other status conditions. With the smaller generators, you typically don't have that capability. So that kind of helps our economics for a fuel cell because, you know, if we only have a 2 kW load, we don't buy a 2 kW fuel cell. We're going to buy a 20 kW. With the fuel cell, we can really size it for the load. Installation, they're both fairly straightforward. I think maybe the fuel cell has a few points there. It's a very simple installation. You've only got your supply and return leads on the DC and some signaling cabling. And all of our fuel cells are installed in an outdoor cabinet adjacent to the building. So generator is a similar installation, fairly straightforward. Fuel, you know, propane is is very easy to site. We'll typically have either a 500 or 1,000 gallon tank. With hydrogen, you have the cylinders. Fuel delivery, is with propane is most of our sites we're only going to refuel once or twice a year, and probably the same with hydrogen. Fuel availability has not been an issue for us. Runtime is an issue. Obviously, we can have a greater runtime with a propane-driven generator. If we can store 500 or 1,000 gallons, we're going to have a lot more runtime than with hydrogen cylinders. Auto exercise, all of our generators will auto exercise. They'll start weekly, and since we're monitoring them, we do this for reliability. We know that if a generator misses an automated run period, that there's a problem, and we can dispatch a crew. And we have the same feature with our fuel cells. They're a monthly. Fuel cells, a much simpler device. That's really one of their big advantages. There are so many moving parts in a standby generator that there are just many, many points of failure, especially with an aging fleet. You've got a cooling system, an oil system, and they're just a lot. We find there's a lot of things that can go wrong with a generator versus a fuel cell that has virtually no moving parts. Maintenance is a big issue with the generators, obviously, because there's so many moving parts to heating system, or not heating, the cooling system, and the oil changes, and just the checks, air filters, all those kinds of things that need to be checked or serviced each year. Regulation is one of the big points for us. In California, we have a lot of environmental regulations, and we have regional air quality boards that oversee our generators. And there's been a lot of new requirements for us to comply with, and so that's been a big issue. With the fuel cells, we have really no environmental regulation. And then reliability. Sometimes it's one of the barriers is just adopting something new and the uncertainty of its reliability. We were confident with the fuel cells. We don't have a long history, but in the short history we do have, their performance has been excellent. I include just a couple pictures of our fuel cell deployments. This was actually the first unit that we installed in 2006. Nothing too exciting here. This is an outdoor cabinet with the fuel cell and the hydrogen cylinders. A couple of others. This is a larger 2 kW unit at a hydroelectric switch yard, and another 2 kW unit at a mountaintop repeater site. So some of the impressions that we've received from our folks as we've deployed these, the field techs have been had a very favorable reaction to these. I think there was some questions about if I don't have any AC, how am I going to have lights if I have to get there in the middle of the night? A few questions like that, but they've generally received these very well. The supervisors that are responsible for maintaining the sites had, as we've gone to different facilities, have had questions and concerns. Mostly it's just been a process of educating them on how it works and how we intend to use them. And they've had favorable responses now from their use. We've also had to work with some of our installations are at leased sites, and so we might have to work with a landlord to negotiate additional leased space to site the fuel cell. And then also the local authorities having jurisdiction, the governing bodies, working with them has also been a very painless process. They've been very receptive.